Hi, welcome. This is Kenneth Wong, Senior Editor for DE 24/7 at the upcoming OzenCon on February 20th at the Computer History Museum in Santa Clara, California. Judy Curran, CTO for Automotive for Ansys, will be giving a keynote talk. So we're fortunate to be able to get a preview of her talk. Judy, your keynote is titled Ansys Vision on Connected Automobiles. Could you explain to us what that vision is?
Yes, absolutely. As vehicles are now connected to the cloud, it provides a lot of opportunity for the OEMs and the suppliers to help the customers. And so what we try to do with our customers is use this opportunity of the connected vehicle to assist the customer with creating new features. So for example, as you have a phone, you are continually getting over-the-air updates of new features. We want to help our customers, automotive customers, do the same for people who are driving the vehicles. So to develop new features and provide software drops over the air for the customers, it requires quite a bit of engineering. So at Ansys, we understand the engineering that's required, and we are working with them to make those changes. Although connectivity implies software and software over the air drops, one of the big changes that has to happen is also the hardware of the vehicle. So in my talk, it's not just about how we help our customers develop new software features, but first get the vehicle set up with the new hardware so that they can do successful over-the-air software drops.
What are some of the things that the automotive industry or autonomous car industry have to overcome to allow this sort of things to happen? Are there any significant hurdles preventing that from happening?
Yeah, I don't think there are hurdles preventing them from happening, but there are definitely changes so that they are ready to be able to be connected and have these ADAS features or autonomous features. I talked about the new electrical architecture. The way vehicles have been developed for the last 100 years, especially the last 30 or 40 years, is every time you wanted a new feature in a vehicle, you would get a module which had hardware in it and the software for that feature. So if you wanted a 10-way power seat, you had a module that gave you a 10-way power seat. If you wanted an infotainment system to provide you navigation on the screen, you had a module that provided you navigation on the screen. But now the features that customers would like is they want to know, oh, I'm getting in the car. I am Judy Curran. Set up my car the way that I like it, the way I like my seats, the way I like my infotainment, the way I like my navigation, and the way I like my steering. And so all of these modules need to be able to work together to provide that feature. And so what you're finding now is that vehicles are not having individual modules for individual features. We're having larger domain and super kind of computers so that you can create these features that are more comprehensive for the customer. And we at Ansys help them design these new architectures from the chip to the board to the module, and then also help them design the software by having our software help them simulate the sensors and the actuators in the vehicle. So the hurdle is new electrical architecture, and the other hurdle is getting models of all the hardware that's in the vehicle.
I've ridden Waymo a couple of times since I live in San Francisco, and they've been operating in the city limit for a few years now. I must say, riding in the car itself gives me more confidence in the car's ability to navigate itself. What are, in your experience, Judy, some of the most complicated or trickiest scenarios to simulate?
Yeah, so your question is specific to autonomy. So for sure, what the industry works on there are these edge cases, like the shadowing of people walking in a shadow coming in front of this vehicle. You've read about some of the various accidents. So the very unusual cases where the sensors would not be able to read the environment that easily. So that would be the most challenging scenarios for autonomy. What I'm finding lately is a lot of the OEMs are not working on autonomy any longer. I mean, you probably read some OEMs have decided not to invest. And I think one of the reasons is that the industry is very challenged right now because the volume of vehicles sold each year is about flat. It's not a growth industry anymore. At the same time, there are a lot of different OEMs that are joining the industry, whether they're Chinese OEMs or West Coast OEMs. There's a lot more OEMs for a fixed volume. And so what they're challenged with is how do I, get more efficient in my engineering, reduce the price of my vehicle, and make sure I get my share of this volume. So sometimes the most difficult thing to simulate is the whole vehicle. And so autonomy works specifically on, the driving of, autonomous in that 7 mile range in that very specific part of the country. It's not really as capable in the whole world. But when you think about all these other OEMs, they're trying to figure out how do I make money on EVs for the everyday consumer that they're counting on to sell their vehicles. And so what I think of the hardest scenarios to simulate is just the complexity of our vehicles in general. There are thousands of components. They come together. They have manufacturing variability in them, and they have different drivers, different countries, different regulation. So when I think of what is the hardest thing to simulate, I still call it simulating the whole vehicle. But we have to do it because that is the way we're going to get more robust. I mean, that is how Waymo was able to get robust in the 7 square miles, was they were able to simulate that area over and over again and get millions of miles and test all their edge cases, right? Take that same thought process to your everyday vehicle, and that's what we are helping our customers to do. So there's a lot of electromagnetic interference. We're able to now simulate that, project that, so there aren't any issues in the field, reducing time, reducing testing. So I would say that's really the biggest challenge. And what is allowing us to do it, I think, as an industry, is that we are helping suppliers and OEMs work more together because suppliers have the components. They're able to now simulate their products and provide encrypted models of their component to the OEM. The OEM can then take those encrypted models along with the parts of the vehicle that they do and actually simulate the full vehicle. So having a digital twin of a full vehicle is still the end goal. We're not there yet, but we're all working together to get there.
There is a lot of talk about AI in the simulation software industry, and our readers are relatively new to it, so they're curious about how to make the best use of it. So I thought I'll ask you that as well. What's the role of AI in specifically as it applies to the software that car makers might use?
So one thing we find is, suppliers provide the same components to many OEMs. So if you're a hinge supplier, an exhaust supplier, a latch supplier, you're providing those components to tens of OEMs, and each OEM is doing, 5 to 10 different vehicles. So in any one year as a supplier, you're designing that same component over and over again with small changes to fit a big pickup truck to a small sports car. And so what we've been using AI for is we've been working with our customers that once they have done this design a few times, we can actually take the design results and simulation results and do a machine model of that, and then be able to create the next design faster. So I'll give you an example. Aerodynamics is an engineering job that has to be done for every vehicle. And so not too long ago, if their designer created a shape of a vehicle, doing a full aerodynamic analysis would take a week to 10 days. And so the designer would have a shape. They'd wonder, is this shape going to work? Is the drag right? Can I get this to have the engineers agree that this vehicle will meet the fuel economy or the battery range? But they'd have to wait that time, right? So then became the invent of the GPU, CPU, a lot more compute power. And all of a sudden, that week to 10 days goes down to 1 day. You can do a full transient run in less than a day. So that is a huge efficiency. But now that you've done this a few times, you can machine learn that simulation result and create a machine model of that aerodynamic result. And now a designer can make a shape change and in 1 minute get feedback that says, yes, that change is positive, we're going to have better drag, or no, that change is negative, it's going to make the drag worse. And so now we have studio artists having the capability to get feedback in a minute. So that's how AI has helped, each of the design processes, that being the aerodynamic example, but that example can play throughout the whole vehicle. Once you do things over and over again, you can use AI ML to provide you data back much faster.
Judy, is there anything else in your talk that you'd like to share or preview with our audience? What else would you be covering in your talk?
For us to get the full benefit out of simulation and out of AI ML and all of these technologies is we need to have simulation be used by most engineers. In the past, it would be used by the CAE engineers of a special department that knew how to use the simulation codes. Now we want to talk about what does it take for every engineer to have simulation on their computer and be comfortable using simulation. So we're spending a lot of time with apps, a human machine interface tools for engineers so that everyone can use it. In fact, we even have our own version of ChatGPT for simulation so that they can ask questions as they're setting up a simulation and our AI tool can help them set up a simulation. And so we are even using that in the training process. So that is one of the key messages is we really need leaders to encourage all engineers to use simulation because the improvement and the opportunity is huge. One of the worries about getting market share of these vehicles is how inexpensive some of these Chinese OEM vehicles are ending up being. Well, for that to be competitive with those new costs, you need to really relook at every part of that vehicle and optimize it for weight, material, cost. And so you need to do thousands of iterations potentially to get the last bit of weight and cost out of that component. Simulation allows you to do that. So if you can get your whole engineering team to be comfortable using these tools, you can find a lot of opportunity in the vehicle. So that is one of the key messages I'd like to talk to the team about. A second message is one I've mentioned already briefly is I think it's very important for the industry to come together by sharing models. For us to have a full digital twin of a vehicle, it does require us all to share encrypted models, and we have the technology now that allows for that to happen. So that's another key point that I try to bring up.
All right, audience, OzenCon is happening in February 20th in Santa Clara. So if you want to know more about the conference and about Judy's talk, go check out their website. We'll also have a link in the article below this podcast. Until next time, ladies and gentlemen, this is Kenneth Wong for DE 24/7. See you later.